Okay, in this video we're just going to do kind of a big optimization problem. It's got quite a bit of pieces and moving parts going on here. So a rectangular storage container with an open top is to have a volume of 10 cubic meters. The length of the base is twice the width. Material for the base costs $10 per square meter. Material for the sides costs $6 per square meter. Find the cost of materials for the cheapest box. Okay, so let me start by just drawing this picture. I'm going to try and, as best I can, do a little bit of simplifying even with my picture. So we're going to draw our box here. Okay. Something like that. Normally, of course, you just say, okay, so length, width, and height. You'll notice right away here it said that the length is twice the width. So you know what? I'm going to write this. I'm going to say length is 2W. And the reason I'm doing that is I'm used to an optimization having two variables, and I have to do some algebra, but I don't want to have three right away. Okay. All right, so we need an equation. Well, we're trying to minimize cost. Okay. So let's start with the base. The base would be W multiplied by L, or W multiplied by 2W. Okay, so the area of the base is W multiplied by 2W, and it costs us $10 per square meter. So I'm going to put a 10 up front. Next, let's go to this kind of front face here. This area of this is WH. Okay, so I could put, WH. But also remember that I have two of them. Okay, front and a back, and it costs $6 per square meter. Okay, now let's look at the sides. Okay, these right here are H and multiplied by L, or H multiplied by 2W. So I'm going to write H multiplied by 2W. And once again, remember we have two of those, and it costs $6 per side. Okay. So now I could do some simplifying. I get 20W squared plus 12WH plus 24WH, okay, which I could write as 20W squared plus 36WH. So here is my cost equation. So all that ugly stuff kind of simplifies out nice. 20W squared plus 36WH. Okay, and remember, this is the thing I'm going to play with. I'm going to have to find the derivative of this. Okay, next. We need an equation that relates the sides to one another. Let me just kind of do that off to the side right here. We know volume. Volume, of course, is length times width times height. For us, it would be length was 2W, width times height, and we know that that's equal to 10. So 2W squared H equals 10. I'm going to choose to solve for H. I think that will be easier because up here in the actual cost equation I only have an H right here. So I'm going to choose to do a H equals 10 over 2W squared, but I could reduce that to be 5 divided by W squared. Okay. So let me write my new cost equation. Okay, I'm just going to put a little break there. Cost is 20W squared plus 36W multiplied by H, which is 5 over W squared. Well, W divided by W squared is just W in the denominator, so I can do a little simplifying. 36 multiplied by 5 is 180, so let me write this. I've got 20W squared plus 180, and it is over W. Okay, I'm going to write W to the negative first because I know I need to find the derivative. I think that will make it easier. Okay, let me find the derivative. dc dw. So 40W minus 180 W to the negative second, which is 40W minus 180 over W squared. Well, we want to set this equal to 0. Okay, so 40W minus 180 over W squared is 0. Maybe add that to the other side. Okay, so I have 40W equals 180 over W squared. Cross multiply. So 40W cubed equals 180. Divide by 40. And I have W cubed is equal to 9 halves. Okay, so W, the width, is equal to the cube root of 9 halves. Now this is not the final answer because, of course, the actual answer was, or the actual question was, find the cost of materials. I'm out of room, and I think this was probably a long enough video, but to find the cost, really all I'd have to do is go right back here, 20 times cube root of 9 halves squared plus 180 divided by the cube root of 9 halves. It comes out to be about $165 if you wanted to plug that in and check it. This is, as I said, a pretty intense optimization problem. There are a lot of little things happening here. Be very careful, setting up your original equation and then working with that equation throughout. This is the equation of interest. We just used the volume to substitute into that.